Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 2.2, which is going to deal with creating and solving equations. So for today, we're going to go through and talk about how we can create equations based off of a description or a story problem, and then go through and solve them. Now, yesterday kind of gave us a brief introduction into this when we talked about expressions, identifying different parts, and how to set it up. Today we're going to really dive more into that, but we're dealing with equations, so we're setting stuff equal to other parts. So, equal signs are involved. Just keep that in mind since we are talking about equations. Alright, so we have one learning goal for today, which is going to be you will be able to use an equation to model and solve a real-world problem. So we're going to go through and model different problems using equations, and then use those models to solve real-world situations or solve the problem they give us. So with that said, let's go ahead and jump into our stuff today. And we're going to have two examples today. There's a plethora of different parts of each example, just to give you an overall view of how to do this in different examples. So with that said, let us begin. Alright, example 1 is going to ask us to write an equation for each description. So we're going to take the description they give us in each part, and we're just going to go through and write an equation. Now, the ones that we're going to talk about for A through F, it just asks us to go through and write an equation. We don't necessarily need to go through and solve it. Now, we're going to use what we know about writing expressions, like we talked about yesterday, to write an equation that represents a real-world situation. So keep those ideas in mind. Now, as we get started with example 1, let's take a look at part A first. So for part A, we have 4 times a number is 16. Okay, few bits of helpful information that you can kind of use moving forward. First of all, okay, just kind of think about the basic terms you've heard before. And when you talk about sum, addition, total, generally you're talking about addition. Okay, less than, minus is going to represent subtraction, times, multiplying represents multiplication, and then say like half or part is going to represent division. So if we look at this part for A, so we have 4 times a number is 16. Okay, a few things to kind of point out. This phrase times is going to represent multiplication. And then we have a number. Because we do not know what that number is, we are just going to go through and set it up as a variable. So in this case, it doesn't really matter unless the problem tells you. Just follow the idea of number. We'll use the letter N. And then this phrase here is going to represent equals. So we have 4 times a number is 16. So 4 times a number means multiplication. And when we've gone through and talked about multiplication with a variable, we can just write that as 4n. Now the phrase is represents equals 16. So then our answer for the equation is going to be 4n equals 16. Alright, so that is how you do A. Now we're just going to run through different examples of that. Really the purpose of this is just to give you a wide range of different phrases or terms, how they're used and how you set them up so you can use them as a reference with homework or an assessment or whatever it may be. Okay, this is a great page to come back and reference on the completed notes or the video if you get stuck on a phrase or term. Alright, so with that said, let's go into B. So part B talks about 10 times the sum of half a number and 6 is 8. So let's break down 10 times. Okay, that's going to represent multiplication again here with times. When we talk about sum, that's adding half a number, but we're talking about half. And then we're going to represent a number as n. And then this and 6 is going to be key. Is means equal. So let's go through and set this up. So 10 times the sum of half a number, n, and 6 is 8. So 10 times is the first part. Now it talks about 10 times the sum of half a number and 6. So sum means that we need to go through and add this part first before we can multiply. So we're going to use parentheses to represent half a number, n, and 6, so sum means addition. So plus 6 is 8, so it's going to be equals 8. Now, that does work. We can simplify a little bit further and actually get rid of the multiplication sign and just do 10 in front of the parentheses. It represents the same thing as 10 times 1/2 n plus 6 equals 8. Alright, so that is how you do parts A and B. As I said, I'm just going to run through the others just to give you some practice in seeing what they look like, and that way I can kind of break down the meaning of each of them. Alright, so let's move on to parts C and D next. We're going to leave A and B there as kind of a reference for now. Alright, for part C, we have 9/10 times a number plus 6 is 51. So this times is going to represent multiplication. Number is going to be n plus, well, it's going to be addition. And then the phrase is going to represent our equal. So 9/10 times a number plus 6 is 51. Now, because it's not talking about 9/10 times the sum of n and 6, like we had up here, sum would represent we have a final solution before we can multiply. Because this is talking about times a number plus 6, we can just write this as 9/10 times n plus 6 equals 51. Okay, the difference between these two problems, when it talks about sum, we have to figure out what these two parts here added together are before we can multiply. Okay, you have to have the total, the sum, before you multiply. This one just talks about 9/10 times that number plus 6. So it doesn't have to be a sum before we can move on. Alright, so that is our solution for part C. Now for D, we have a number minus, this is going to represent subtraction, 11 is 12. So a number minus 11 is 12. So if I use n as my number, so it's going to be n minus 11 equals 12. Now, something just to be aware of, and I'm going to write a note off here on the side, and this isn't in the completed notes. If you're watching the video, you get this that is not on the completed notes. Let's say that I talked about n less than 11. Okay, and I think that came off the paper, so we'll move it over. So if I talked about n less than 11, what that would mean, instead of n minus 11, it would end up being 11 minus n. Okay, less than is going to imply subtraction, but it's not n minus 11. yet we have to go through and flip the order to make it 11 minus n. So something to be aware of. Subtraction and division are going to be the ones that the way it's phrased could represent something different. All right, so moving on, let's take a look at E and F. So these are going to bring in some story problems for to go through and solve. All right, for E, Hector is visiting a cousin who lives 350 miles away. He has driven 90 miles. How many more miles does he need to drive to reach his cousin's home? All right, so Hector's cousin is 350 miles away. He has driven 90 miles, and it wants to know how many more does he need to drive. So, first of all, we have our numbers 350, 90, and then we want to know how many. Okay, because we do not know how many more he needs to drive right off the top of our head, we're going to represent this as M for how many miles left. Okay, so M is going to represent for miles remaining or miles left to drive to get to his cousin. So if we go through and set this up, okay, we know his cousin is 350 miles away. So that is going to be our starting point. Now that's going to be equal to whatever he has driven or needs to drive. So it's a total of 350. He's driven 90 miles. And then we want to know how many more. Well, it's 90 plus how many more left. Excuse me. So we're going to do it as plus m. Now, it does kind of ask us how many more, but in this part, I really just want you to practice setting up equations. I think you could solve that. So we're just going to leave it as that because I want you to write an equation. So 350 equals 90 plus m. You could also write this as 90 plus m equals 350. All right, now part F is going to be the same type of situation, just different scenario. So we have raising money for a school fundraiser, how much has been raised so far, how much needs to be raised left to reach the goal. Okay, I'm going to leave part F for you. Reference this as a guide because it's the same format, just different scenario. And if you want to, you can check the completed notes to see what that's going to look like. All right, so last part of example 1 is going to be G, which is going to kind of give us a little bit more of a different situation. So if we look at G, we have a rectangular garden is fenced on all sides with 256 feet of fencing. The garden is 8 feet longer than it is wide. Find the length and width of the garden. So, a few things. Okay, we're told that the garden is 8 feet longer than it is wide. So the length right here, so this is going to represent our length, is 8 feet wider, so plus 8, than the width. And the W is going to represent our width. Now, it wants us to find the length and width of the garden. So that's what it wants us to find. And then it talks about fenced on all sides with 256 feet of fencing. Okay, what that means is if I went through and added up all 4 sides, that would be 256 feet, meaning we're talking about perimeter here. So if we're looking at the different parts, okay, because we're talking about a rectangle, opposite sides are equal. So this is W plus 8, that means this is as well. If this is W, that means this is W as well. Because we are talking perimeter, okay, just a quick note as a reference that we'll talk about throughout class. To find perimeter, you add up all the sides. So we would go through and add up all the sides to find the perimeter of this. Now, yes, I've written L, but kind of ignore that because they didn't really tell me that. That's just kind of as a way to reference that this is the length, and I'll just go through and write that a little bit more so you don't confuse it. All right, so perimeter, we're going to go through and add up all these parts and set it equal to the total. So if we start out with the length, it is, and we'll change colors here, W plus 8 plus W plus W plus 8 plus W. And that is going to equal 256 because that's our total length around the fence. Now, we can go through and solve this. We're going to go through and simplify this first. So what we're going to do is combine like terms. So I'm going to combine all my W's. So I have 1, 2, 3, 4 W's. So it's going to be 4W plus, and then we have 8 and 8. So that gives us 16 equals 256. Now, that is how you go through and set that up. Now, if you want to go through and solve it to figure out what W equals, you would subtract 16 and then divide by 4. So that would give you what W equals. And if you want to go through and practice that, know that W is going to equal 60. So if I find out that W equals 60, if I want to figure out the length, okay, my length is W plus 8. So you just do 60 plus 8, and you find out that your length is 68. So I will leave that to you if you want to go through and practice solving to see if you can get those numbers to make sure your solving skills are on point. But that is how you would do it, and that's kind of an abbreviated way of solving. All right, so with that said, that is all of example 1, all the different parts. What we're going to take a look at next is example 2, where it's going to ask us to go through and set it up and then solve. And these ones are going to be a little bit different situation. So, on to example 2. All right. So, example 2 is going to ask us to write and solve an equation to solve each problem. So, for A, we have Janine has a job offers at 2 companies. One company offers a starting salary of $28,000 with a raise of $3,000 each year. The other company offers a starting salary of $36,000 with a raise of $2,000 each year. In how many years would Janine's salary be the same with both companies, and would the salary be? So, first things first, when you get these comparing type problems, what's helpful to do is go through and write an expression for each company, and then because we want to know when they are the same, that means that we're going to set them equal to each other, okay? Because that's what we're looking for. Same means equal. So we'll just set both expressions. So if we look at our first company, and I'm going to call this company A. So company A offers a starting salary of $28,000 with a raise of $3,000 each year. Now, we're going to go through and write an expression for company A based off that situation. Now, I need a variable to represent years. Doesn't matter which one you want to use. Some people are most common and comfortable with X. You can use X. I'm going to use Y in this case for years. On my completed notes, I use X. Just matter of preference. All right, so for company A, we are told they offer a starting salary of 28,000 with a raise of 3,000 each year. So we start out with 28,000 and then we get a raise of 3,000 each year. So it's plus 3,000 every year. Now the other company, company B, offers a starting salary of 36,000 with a raise of 2,000 each year. So company B is 36,000 plus 2,000 each year. So that is how you go through and set up and write your expressions for each company. Now we're going to go through and solve these by setting them equal to each other and then solving. So let's do that now. So we're going to have 28,000 plus 3,000y equals 36,000 plus 2,000y. Now, I know there's a lot of different numbers, larger numbers. They will simplify here shortly. Something to kind of know before we go through and solve this. Okay, company A starts at a lower amount, but if you compare the raises, they provide a raise that's larger every year than you get for company B. So B, you start out with more money, but you get less of a raise every year. What this means is initially you will get more money from B, but eventually from A, you will end up making more money after a certain amount of time, and that's what we're going to figure out. So we need to go through and solve. We have variables on both sides. Okay, so we need to get the variable on one side. I generally like to move the variable to the side where the number is larger. So 3,000y is larger than 2,000y. So my first step is going to be moving the variable to the left. Now because this is plus 2,000y, that means I need to do the inverse operation, which is to subtract 2,000y. Now remember, when you're adding, subtracting, or to one side or to both sides, you have to do it to like terms. So I'm only doing it to the y's and to the y's. There is no y here or here, so nothing changes from those. So I end up with 28,000 plus 1,000y equals 36,000. Okay, because 3,000 minus 2,000 gives us 1,000. All right, next we need to move this 28,000 over to the 36,000. This is a positive 28,000, so that means I need to do the inverse, which is subtract. And when I do that, that cancels out like the y's did up here. So I get 1,000y is going to equal, if we do, just to show you, if I do 36,000 minus 28,000, okay, we end up with 8,000. So I have 1,000y equals 8,000. Well, if I do 8,000 divided by 1,000, just to kind of show you guys, we would end up as 8 as our answer. So it takes 8 years for the amounts that she would make in salary to be the same. So that's the first part of the question. How many years does it take? The second part asks us, what will the salary be? So what you're going to do is take this value of 8, you're going to plug it into just one of these two equations. Okay, you can plug it into both. It's kind of redundant, so we're not going to do that for both. But let's take it and plug it into the top one, just because that one's first. So we're going to take 28,000 plus 3,000 and then we're going to multiply that by 8, and then we hit enter, and we're going to end up with 52,000 as the amount. So that is going to be the second part. So in 8 years, Janine will make the same at both companies. And the amount that she'd be making in 8 years is 52,000. All right. So that is how you're going to go through these specific problems. Now, we have 2 more that are going to be similar to it. We can take a look at B and just kind of move from there and see how things go. So let's go ahead and move this up for B. So that is all we have to do for that one. And let's get off and rolling with part B. So for part B, we have one moving company charges $800 plus $16 per hour. So already I'm going to call this company A. So they charge $800 plus 16 per hour. Another moving company, let's call this company B, charges $720 plus 21 per hour. So what this means is the first moving company A initially is going to charge you $800, and then it's $16 per hour after that. Moving company B is going to charge you less initially, but more per hour. So the question is going to ask us, what are the number of hours they both will be the same? So again, we're going to set these equal. And then what is the charge? So if we're going to set up for company A, company A talks about 800 plus 16 per hour. And I'm going to represent hour in this case with an H. So H is going to be the number of hours. I'll make that look a little more like an H. All right, and then for company B, we're told 720 plus 21 per hour. So it's going to be 720 plus 21H. So I have my 2 expressions now. Now to set it up as an equation, we just have to set these equal to each other. So it's 800 plus 16H equals 720 plus 21H. Now, if you were to run through and solve this problem, and I'm going to leave that practice for you, okay, if we go through and solve that, we would end up with H equaling 16. So what that means is it takes 16 hours for them to be the same. And the amount in that case, if we plug 16 back into one of these ones, and again, I'm going to let you practice that, you should get 1,056 for the amount. All right, so I will leave that for you to practice going through and solving for H. So remember, move the H to one side, move the number to the other side, and then divide, and you should get your answer. All right, for part C, I'm just going to talk about the setup. I'm going to leave this one for you to practice. It is done in my completed notes, but I'm just going to help you understand how to set it up. So for part C, we have Claire bought just enough fencing to enclose either a rectangular garden or a triangular garden as shown. So rectangle, triangle. The 2 gardens have the same perimeter. How many feet of fencing did she buy? So they give me the 3 sides of the triangle, and they do give us the 4 sides of the rectangle. Just remember that opposite sides are equal. So that side is going to be 3x minus 3, and this side is going to be x minus 3. Now, As a quick reminder from the front side, perimeter means we add up all the sides. So what you're going to do for both of these is you're going to go through and add up all 4 sides for the rectangle, add up all 3 sides for the triangle, and then you're going to set those 2 expressions equal to each other, figure out what x equals, and then when you figure out what x equals, you plug it back into one of them. Now, I will help you set up one of them. I will leave the other one for you. Because we've already talked about a rectangle before, I'll leave that one for you. So the perimeter for the triangle is going to be 2x minus 1 plus 2x. So 2x minus 1, 2x, and then plus 2x minus 1. So I have a 2x, 2x, and 2x. So 2 plus 2 plus 2 is going to give us 6x. And then I have minus 1 and minus 1. That gives me negative 2. So that's going to be 6x minus 2. For this one, when you go through and add up all 4 sides, just to give you a reference, you are going to end up with 8x minus 12 when you add all those up. So like I said, once you've gotten to that point, you just set these 2 things equal to each other. So you would have 8x minus 12 equals 6x minus 2. Find what x equals, and then you're going to plug that value back into one of them. So I'll just set one up for you. So I just plug it back into the rectangle. So you do 8 times that value of x minus 12, and that will tell you how many feet of fencing she bought. All right, so with that said, that is your lesson for section 2.2 on creating and solving equations. That is it for today. So that is your lesson. Thank you for listening. If you have any questions, just reach out, or next time you see me, let me know. Again, come back to this video for reference, or take a look at the guided notes or the completed notes to help you also go through and do your homework today. So that is all that I have for you guys today. Again, thank you for listening, and have a great rest of your day. All right, bye.